Good day. This is video number 2 of our assembly here that we're creating as a top-down design. And today we're going to focus on the wheel, and we'll also create the shoulder bolt, or we may create a separate pin and the appropriate bushings. I think I may have to edit my hole size because the bushing outer diameter is 1 inch. With a forced fit of an FN2. So the idea is that we'll end up having to go back here and adjust the size, because I think I made that 3/4 of an inch in the last design, and we'll update that and we'll move forward. Alright, so that means we have to go back to the angle bracket, and we can double click in the angle bracket, or we are actually still in the angle bracket drawing, because the holes that I created are still listed in the history at the bottom of the screen. The hole listed here for the angle bracket, I can double click or right mouse click and edit that hole feature, and I can update this hole with a diameter from a 0.75 to a 1 inch. And that's all I have to do is just update the 1 inch and choose OK, and now that hole has been updated and we're ready to go. So we need 2 of these angle brackets, and so the easiest way to copy an angle bracket is actually use the Windows copy and paste routine. And so this angle bracket 1, we can right mouse click and choose the copy option, and then we can use the Control V on your keyboard and paste it. Well, when you paste it, it actually pastes it over the exact same position, but it gives you the move command to move this around. So what we're going to do is grab the arrow, and this is going to be the horizontal arrow. We're going to move this out of the way, and we're going to rotate it. So we want to rotate it 180 degrees. Bingo. Once that's done, we'll choose OK, and it's going to create this as a new component. So now we've got angle bracket 1 and an angle bracket 2, 2 separate components in our design. And since we updated the hole size before we copied it, the hole size is automatically updated. And so these 2 are linked in that realm. They are not independent of each other. So the next item that we need to create is the wheel. And that wheel, as you can see, has got a groove in it, and it has an outside profile. And the easiest way to create these is with the rotate capability. Create a profile and then rotate that profile all the way around to create the wheel itself. That's the easiest way to manage that. So we'll end up having to create a new component as part of this. So under the assemble, we can create a new component. Now each one of these is so let me explain it a step back here. We just copied this, and it's not a component, this is a body. Or take it back, it is a component because we copied it as a component. So, excuse me, it is a component. So we're going to create another new component in this design. And the easiest way to do that is to choose new component. It'll come up as a standard component. We got to give it a name. We'll call it wheel. Is it going to be based on the parent, which is the base object, or is it going to be based on a specific body or an object? And it can be based on the original parent, which was the base plate. And that's fine, and we'll choose OK. And so now we have the new wheel component. We need to create it as a sketch. So we'll choose sketch. We have to choose a sketch surface, so we're going to choose the vertical sketch surface here. And then we'll look at it in the front view. Now granted, all the parts and pieces are still in the positions that they started. but you can see that they're kind of ghosted at this point. And again, all we need to do is create the profile, and then we'll generate the shape of our wheel. And so to create the profile, we're going to need to create a design that looks something like this. And it doesn't matter where it happens to be. However, we are going to have to create this. And I'm going to go ahead and create this a little bit higher up so it's out of the way. We're going to draw a horizontal line as our center line, and we'll change this to a center line in just a second. We can actually right mouse click, and it should allow us to make it a normal construction line or a normal center line. And so it's now a center line. We'll create a new line, and this new line we'll start out, and looking at the design of this wheel, we're going to have to start out, create a base, and let's see here. Yeah, it's going to have to come up and then come back in. So it's got an interesting design here. We're going to create it. Up. And then we need to create it coming back in. So we've got the vertical, we come back in a little bit, and then we go vertical, and then we come back out. And then we come up. And then we end up creating the V, and that's about in the center. And we could stop it at this point. And the reason why I might hit the escape key is because we could create another construction line from here, straight down. Choose OK, and then mirror this shape. And I can delete this line. So we could just take this shape and mirror it once we have dimensioned it appropriately. We can go ahead and use the trim command and trim this line back. And now we've got half of our shape. And we don't have everything constrained or dimensioned as of yet. So we know that the inner, let's see here, it says the wheel diameter is 4 inches tall. So from the top to the center point is going to be 2 inches, because the overall wheel would be double that. So let's go ahead and dimension this. From here to here, it's going to be a diameter of 4 inches. So right now it's a diameter of 6 inches. So if I type in 4, what's going to happen? Okay, see where the center line moved. Well, we don't want that to happen, so let's undo that. Okay, we'll leave it at 6 currently. What we're going to do is now add in the hole size, because this is the hole in the object. And let's see here, body hub width is 1.5 inches by 0.75 OD. Groove is 45 and centered. Okay, so the wheel diameter is 4, width is 1, body is 1/2 inch thick, hub width is 1.5 by 0.75 outside diameter. So this would be 0.75. This indicates it's 1/2 inch thick. The hub distance, seems awful thick here. Seems awful thick at 1.5, because what it's telling me is that this to here would be 1.5 inches, or in essence 3 inches, and that seems awful thick. So I'm going to leave it at 2 inches because I think it looks better, and we're actually going to kick this up to 1 inch, which is the size of our other hole. And now that we've got some constraints on this, we could change this. However, there's a couple of things that I want to make sure that are set. Because again, what we're doing is we're dimensioning critical items. This needs to be 1/2 inch. Okay, so this distance needed to be 1/2 inch. The width, body is width is 1 inch. So this is also set up as a 1 inch distance. So right now it's 1.2, so set that up as 1. So that's looking much better. And now we can set this as an overall diameter of 2 inches because all of our critical dimensions are now set. Okay, the dimension for the hole, the dimensions, all the horizontal dimensions, the critical dimensions are set up, and we'll set that at 4 inches. But it's still flip-flopped. And so when things like this happen, when it flip-flops, we can actually grab and move entities if we choose, if we can. Sometimes that happens, and it gives us the ability to grab that and move it. I have to get out of any dimensional environment, and you can see that I can grab and change that and move this position. So you can grab that entity that was thrown out based on that we didn't give it a dimension because it wasn't held fast, or we can undo it, give it a dimension, and then redo it. So this dimension needs to be 1/2 inch because that's what it said, is that all of these objects needed to be 1/2 inch. So let's go ahead and dimension this at 1/2 inch. Seems awful thick, but that's what it's telling us that the values are. Alright, so the next thing we have to do is mirror this. We have to mirror this to the other side. So we're going to mirror the sketch, and then we're going to revolve the sketch to create our part. So there is a mirror option under modify. And so, let's see here, where is mirror? We have symmetry, offset, move copy, and mirror. I knew it was there. So we can use the mirror tool. The big thing is we have to select everything that we would like to mirror. So what we can do is pick all of the objects that we would like to mirror and just walk our way around. And yes, can this be tedious? It sure can. Can you use a window? Absolutely, you can window around it. But we now selected everything that we would like to mirror. Now we need to pick a mirror line. The mirror line that we would like to pick is here. So it originally selected this object as our mirror line, that center line. Okay, that makes sense, but that's not what we need. So we have to deselect it. And typically holding the Shift key and selecting the object will deselect an object. So holding the Shift key on the keyboard and selecting it will deselect. And this time we're going to go ahead and mirror by picking, oh, it won't allow us to select this, it wants a center line. Alright, so let's take a step back and draw a construction center line to mirror with. So we'll just draw a line here, pick it, right mouse click, and make it a center line. Use the mirror tool select our objects again, and this time we can window around it, and what he did was left mouse click hold, window around the objects, select the mirror line, which is the construction line, and you can see that the shape of the object is now mirrored horizontally. It really does want that center line to be the mirror. And we can choose OK. And now we've got a shape, and we could theoretically remove the center line because the center line does not change the shape of the object at all. So now it's one solid object just by selecting or highlighting that center line and hitting the delete key to get rid of it. We'll finish the sketch and we'll revolve. And the axis of revolution, since we have two center lines here, it wants to know what the axis of revolution is. And that's our axis of revolution. So this is our object. It looks a lot different than what is actually being displayed, but we're going with the dimensions that they're providing us. So now we've got the wheel. Okay, so we've got the wheel. So the next step is once we have the wheel, we now can create either the shoulder bolt or we can create a pin to go through here, so that way we can revolve this object. And so creating a shoulder bolt is an assembly kind of thing. We can actually use a bolt and build a bolt under the assembly environment, but we can also just create another new component to make a bolt and physically develop our bolt ourselves. And so it wouldn't be too hard to do that. The big thing is we want to use the correct diameters and information. So what we have, or what we know, is that inside these 1-inch holes we have we're going to have some bushings, and those bushings will change the diameter. Let's see here, the inner diameter is going to be 5/8 of an inch. Well, theoretically, this wheel with a 1-inch diameter here, that's not going to work well if this is going to be a 5/8 hole. So again, we can go back to the wheel, go back to the sketch and edit the sketch. And remember, we questioned that when we were looking at this design, that this hole of being 1 inch seems to be large, but that's what they spec. They actually spec 3/4 of an inch. So, we could say we want to make this 0.75, and then this distance here, we can make this 1.0. And that's awful thin, so we might go 1.25. And so yes, we're changing the part a bit. However, what we're doing is we're going back and looking at the other components and saying, well, how does that all fit together, and is this the right design for that? So as an engineer, you don't necessarily want to question everything, but when things don't match up or the information that you're given is not consistent, you want to ask questions. And we'll finish the sketch, and that now updates the part with a better hole in that wheel. Alright, so looking at that, we can create the bushings. Those are easy to create, and we can then develop the shoulder bolt after the bushings, or a shoulder pin after the bushings. So we'll again create a new component. So we'll select new component, standard. The component that we're going to call is bushing. And what we're going to do is create a sketch. Makes no difference, but we're going to go ahead and create it on the YZ platform here. We'll look at it from the right side view. And the bushing, we're just going to make it really simple. It's going to be a couple of circles here. So it's going to be an inside circle with an outside circle, and we'll put some dimensions on it. And so the inside needs to be 3/4 of an inch, diameter. The outside needs to be 1 inch in diameter. Okay, and we'll finish the sketch, and we'll extrude this to a thickness of a 1/2 inch. We just want to extrude the outer edge, and we want to extrude this, and our extrusion box is over here on the right hand side. The distance is going to be 0.50. Now it's telling me that the outer diameter is a 1/2 inch and the inner diameter is 5/8. Okay. Since we're designing our own pin, as opposed to using a standard socket head shoulder shoulder cap screw, more or less, we could go either direction. We could make this 5/8, and we can always come back and edit this also. So that's one of the things that we have the ability to do, and it's going to create it as a new body. And so we've got a new body under this feature. Body sketches, bushing. And so theoretically I should be able to move the bushing up above the wheel. However, the wheel, the bushing was created based on the wheel, so that's not good. So let's go ahead and we could change this. So one of the cool things is that we can change a body, which is what the bushing is, which is tied to the wheel, to a component. And so we could create this and edit this object and make it a component here. So what we did, we right mouse click on the bushing, and let's see here, there should be an option to change its feature capability to a component. And I might need to be out of the object before I can do this. I can create a new component, but I can change a component. So right now this bushing is activated. So let's go up and activate the base plate. If the base plate is activated, and I can right mouse on this, show hide, the bushing. Just looking to see here, I'm looking at how I can transfer this bushing to make it not part of the wheel. And so I may have to go in and edit this and recreate this outside of this wheel. Or I can save a copy as a possibility as another component. So there's different ways to work on this. We'll solve this problem in just a second. So the bushing is there. It is part of the wheel. We want to actually be part of the base plate to create this next object in the assembly. And what we want to do, to take and insert a shoulder bolt or any bolt, we go through the insert option, and we insert based on McMaster Carr. And so the McMaster Carr is a catalog of pretty much every type of fastener and component that you might need. So we go into the McMaster Carr, and theoretically you can buy directly from McMaster Carr. So this is part of the thinking of having their database associated with this. And so we can go to screws and bolts, or threaded rods, or spacers and standoffs, and there's quite a few different things that we could do with this. And again, this welding and brazing and pipe fittings and power transmissions and shaft information. And so all these components are items that you can purchase through McMaster Carr, but you can also bring them into Fusion 360. But in our case, we're going to be looking at screws and bolts. So we're going to be looking at a socket head, because that's what it indicated that it was a socket head shoulder screw. So we're going to do socket head. Now there's different types of socket heads. Socket head screws, ultra low profile, high profile, meaning the size of the head. We're just going to go with a standard socket head. And then the type. So there's different types, Torx, which is a torque configuration, because a typical socket head will have a Allen wrench configuration. And so alloy steel is fine, not a military specified or a left-hand screw. High temperature stainless steel is also common. Chrome plated, cleaned and bagged, corrosion resistance, titanium, brass, aluminum. So again, you can select the type of socket head that you might need. So we're just going to do an alloy steel, because those are usually the easiest. And ours is going to be partially threaded, hence the shoulder. This is considered the shoulder of the socket head. So it's partially threaded. Now, there is a long list of different socket heads. So now that we've selected the type of product, we can go to the thread sizer and start to work with this. So ultimately we need a 5/8 diameter shoulder. So let's see here. So it gives us thread pitch and length and threading. We want it partially threaded, socket head profiles, drive style, head diameter are choices, minimum thread length, coarse, fine, and extra fine. We learned about those. Head height, thread type, drive size, and I was just looking to see if there was anything with the shoulder distance. So ultimately, the overall length of this shoulder bolt is not provided. So knowing the distances here of a 1/2 inch thick for the plates, that's 1 inch. The wheel is at least 1 inch to 1.25 inches. So that's now 2.5, and we could do easily another 1/2 inch, if not more, for just the fastener, the nut component. So, we're looking at a 2 to 3 inch overall length. But as indicated, we have to pick our thread size first. And so our threads, looking at the way that the hex nut is, it says that it's a 1/2 inch 13, which is a unified national course. So here's a 1/2 inch 13 for threading. So now this is our 1/2 inch 13, and we've got a variety of different sizes. And so I'm thinking 3 inch may be the appropriate distance here, though I'm also thinking that it might be too long. So 2.5 inch might be the appropriate length here, because it's 1/2 plus 1, it'd be 2 plus 1/2. Okay, we can always update it and make it 2 3/4 if we need to, but we'll go 2.5. And we don't need a Solidworks file. What we need is, let's see here. Well, we could bring in a Solidworks file. That is appropriate. That would indicate or work for our design. Okay, so with this, we could download the Solidworks, but the step file works the best for Fusion 360. Fusion does allow importation of Solidworks files, but then it would have to go through an import process. So we're going to go ahead and download the step file, and we'll choose download. And there is our socket head cap screw. However, it looks like it's not rotated properly, so we can rotate the socket head cap screw appropriately, and we can accept it. Alright, so theoretically, that's what came in. It isn't really what we're looking for as a shoulder bolt, but that is what the specifications indicated as we set this up. So bottom line is we may have to go back and delete this, and we can't really edit this because as a step file we don't have all the data with the step file information. So we'd have to go in and delete this object and then either insert another one, or in our case we're going to go ahead and just design a pin to accomplish our task. So that will be in our third video, and so we'll design the pin and we'll take this and finish the assembly process. Have a great day.